Alright, in this video we're going to talk about circuit analysis and how to construct loop equations. So I have a question here which says apply Kirchhoff's laws to find the currents I2 and I3 and find the value of R, the resistor R. So before we do anything, let's review the most important laws in circuit analysis, which are Kirchhoff's voltage law and current law. So the first one, Kirchhoff's current law says the current entering a junction is equal to the current leaving it. So this law describes the conservation of current. It says you cannot make more of current and you cannot lose it. The total current you have at the beginning is the total current you're going to have at the end. So let's say maybe for this junction, a current, the main current enters the junction. Let's call this I1. So I1 enters the junction. As it reaches the junction, it's going to split into two currents. So you're going to have I2, and in this branch you're going to have I3. So maybe let's say this current I1 is 5 amps, which means this current, the main current entering, is also equal to those two currents, to the sum of those two currents. So maybe let's say if this is going to be 3 amps, then I2 is going to be 2 amps. Because if you add them, they both have to give you 5 amps. So this is what Kirchhoff's current law basically says. For the second law, which is Kirchhoff's voltage law, it says the sum of all voltages across the circuit should always add up to 0. So the voltages you have as you move around the circuit, the voltage drops and the voltage rises. As you sum them up, they should always give you 0. Alright, so knowing this, let's go and solve the question now. So for this question, we have been given I1, which is 1.3. That's 1.3 amps as the main current. And as it enters this junction, it splits into I2 and I3. So this is the junction. So I1 is our main current. So now, the first thing you have to do, this question has been given. We have components in the circuit. We have resistors and batteries. So now, the first thing you're going to have to do is identify the polarity of the batteries, which is very important. So for the battery, let's look at this 4-volt battery. The polarity, when you see the longer stroke is the positive terminal and the shorter stroke is the negative terminal. Likewise for this one as well, this is the longer terminal, so this is the positive, and this is the shorter terminal, this is the negative. So now that you've identified the polarities of your battery, you can now move on to proceed to make Kirchhoff's voltage law and current laws into your equations. So for the first one is KCL. So let's say equations on top here. So for our equations, the main current is I1. So I1 enters the junction and then splits into two currents. So I1 is equal to I2 plus I3. So that's Kirchhoff's current law right there. And then you're going to move on now to Kirchhoff's voltage law, summing all the voltages in the circuits that you have. So now, what you have to do is, you have to split this diagram into loops, or you have to identify your voltages in two different loops. So what you're going to have to do is, you first have to know what a loop is. So a loop is a closed path in which current flows. And a loop starts from anywhere on your diagram. So for this particular diagram, we're going to have two loops. And we can start from anywhere. So let me start by identifying loop 1. So for my case, I'm going to start at this point, this junction. I'm going to call this Y. You can also start here, you can also start there, whichever is your preference. But for me, I'm going to start here. And for the loop, your starting point is also your ending point. So if I start at Y, I go around the circuit this way, come down there, I have to go back to Y, and that's my first loop. Or I can go this way. I go up there and I return back to Y. That's also another loop. So for my first loop, I'm going to cover this part of the circuit and then come back here. And then this travel of current is what's going to make up my voltage equation, this one. So I'm going to call this my first loop. So this is loop 1. So before the equation, let me mention what happens when each component of the circuit, how they react when current passes through them. So the first one, we have the resistor. So for the resistor, what happens is, so when you have a resistor and then you are going with the current is going this way. So for the resistor R, let's call this R, it's always going to be a voltage drop. So you know that according to Ohm's law, voltage is equal to IR. So the voltage across this resistor, which is a voltage drop, which means it's a minus, is the resistor multiplied by the current passing through it. So now, since I'm passing through a resistor, this is a negative V. But now this changes when you have a resistor and then you know that the main current maybe is coming from this way. And then for your loop, your assumed current, maybe you are starting from this way, from this side, going this side. When you are opposing the main current, this resistor becomes a plus. So it's going to be a plus, it's going to be a voltage lift. So therefore it's going to be a plus IR in this case. So that's what happens for the resistors. And we're going to see this in the question. But for the battery, when you talk about batteries, for your batteries, you have two terminals. So you have the positive terminal and the negative terminal. So when you're coming from here, current is coming from here, you're going to the other side, you're crossing this battery. What happens is, when you're coming from a higher potential, which is the positive, going to the low potential, the sign is always going to be the sign of your destination, where you're going. So you're coming from high potential, which is positive, going to low potential. So this is going to be a negative V. But if you're coming from, maybe let's say, yeah, this is going to be the positive now. Sorry, this is the negative. For the negative, then you're going this way. So now current is coming from the negative side going to the positive side. So this is coming from the lower potential going to the higher potential. So you're going to the positive. So now it's going to be a voltage lift, which is a plus V. So for this battery, maybe let's say the batteries were 30 volts. So for this one, if you're coming from this side, this is going to be a negative 30. But if you're coming from the negative, this was going to be a positive 30 volts. So that's how you treat the components of the circuit. So now let's start with the first loop. So I have my first equation, let me call this A. For my second equation, for my first loop, so I'm going to start from Y, going up like this and back to Y. So the current passing through this branch is I2. I2 is going this way. So now I start from Y going this way. So I meet the 2-volt battery. So I'm coming from the negative side going to the positive side. So I'm coming from a low potential going to a high potential. So this is a plus 2 volts. So we're done with the battery. Then you come to the battery, you come now to this 2 ohm resistor. So for the 2 ohm resistor, when you're going with the current, it's always a voltage drop for the resistor. So it's a minus. So it's that resistor multiplied by the current passing through it. So it's a 2 ohm resistor and the current passing through it is the I2 current. So now you're done in this branch. Now you go up, you climb up. Now for this one R, for the resistance R, so your assumed current is going this way. This is where your assumed current is going. But the actual current I3 is going this way. So now you started from this side, going this side. So now you are going against this current because you're coming this way, you're coming from this side, you are going against the main current. So this won't be a voltage drop across this resistor. Instead, it's going to be a voltage lift. So it's going to be a plus, and it's for the voltage is the R, the resistance multiplied by the current passing through it. So the current passing through this resistor is the I3, which is coming up that branch. And then just like that, you come back to Y and your loop is done. So now you equate this to 0, and for your first loop you are done. For your second loop, let's call this bottom loop loop 2. So I'm going to maintain my starting position, which is Y. So now I'm going to go down this way. You can also go this way, but I'm going to choose this side. So it's going to be the same as I started. So I meet the 2-volt resistor, so it's a voltage lift, so it's a plus 2, the minus the 2 ohm resistor with the I2 current passing through it, and then I come down. I meet now the 3 ohm resistor. So I meet the 3 ohm resistor and I know that the current is going this way, so I'm going with the current. So now this is a voltage drop. So this is 3 minus the current passing through here. So the current passing through here, we're using I2. So this is I2. And then you meet the battery now. So you're coming this way. Now you meet the battery. So you're coming from a low potential going to a high potential. So this is a voltage lift. So it's a plus 4. And then you come back to Y as your endpoint. And then you equate this to 0. So those are your equations. So it's very important that you get the polarity of each component in the circuit correctly, or because one slight mistake in a sign or misarrangement could break the whole thing and your answers are going to be wrong. So now that we have our equations, we know that our I1, so for the first equation is I1 is equal to I2 plus I3. So the question has already given us I1, which is 1.3, which is equal to I2 plus I3. So we have that equation. So now we're going to use this equation. So now to find those currents, I2 and I3 and the resistor R, you use now these equations. Now basically at this point it's just a substitution game that you get to play. Once you reach this far and you get these equations correctly, you've already answered the question, because now you just start plugging in things and then hoping to find the other thing. Alright, so now let's find I2 and I3. So we have two equations here. In this one I have this one having I2, this one having I2 as well. So I'm going to start with this one. This is the most simpler one because this one has I2, it has R which we don't know, and it also has I3 which we don't know as well. So this one has three unknowns. So this is going to be last. So let me get this one. So this equation says it's 2 minus 2 I2 minus 3 I2 plus 4, and it's equal to 0. So now I have two like terms. They are both I2. So different signs, sorry, same signs. Okay, so this is minus, you add them, 5I2 plus 4, which is equal to 0. Now that we have that, let's make a substitution. We know that I2, in this equation we have I2. So now we can substitute this and make I2 the subject of the formula. So for this one, it's going to be I1 which is 1.3 minus, this crosses the equal sign, I3, and it's equal to I2. So now we know that I2 is equal to this. So we will substitute this into this equation now. So it's going to be 2 minus 5, and our I2 is 1.3 minus I3, close the brackets, plus 4 is equal to 0. And then you're going to have 2 minus 5 times 1.3, that's basically that's 6.5 plus, so negative times negative, that's a plus, that's a 5 I3 plus 4. At this point, let's collect our like terms. So you have 2 minus 6.5, this is a negative 4.5 plus this 4, and we're going to cross this 5 I3 to this side, and it's going to have a negative sign. Alright, so negative 4.5 plus 4, this is negative 0.5, which is equal to negative 5 I3. And then now you just divide both sides by negative 5 to find your I3. So your I3 now, that's negative 0.5 divided by negative 5. So your answer is a positive 0.1 amps. And that's your I3. So now, if you look at this first equation, I1 is equal to I2 plus I3. And then we rearranged that equation. We said I1 minus I3 is equal to I2. So now you have I1, it's been given in the question, and now you finally found your I3. So which means your I2 is just a piece of cake now. So this is just 1.3 minus 0.1, and your difference is your I2. So the difference there is just 1.2 amps, and that's your I2. So now you finally have all three currents. I1 was given beforehand in the question, that's 1.3 amps. Now your I2 you found is 1.2 amps, and finally your I3 you found it 0.1 amps. And if you add I3 plus I2, it should give you this one, 1.3, because the current entering a circuit is always equal to the current leaving it. So those are your I's, those are your currents. The only thing left now is to find the value of R, the R resistor. So to find R, we are going to use the equation that has the R resistor. which is the B equation. So it's 2 minus 2I2 plus R, which is I3, and this is equal to 0. Okay, so now we have 2 minus 2, our I2 is 1.2, plus our R, our I3 is 0.1. This is equal to 0. So now you have 2 minus 2.4 plus 0.1 R, it's equal to 0. So the difference of these two is negative 0.4, which is equal to, you cross that, it's going to be 0, negative 0.1 R. So you divide both sides now by negative 0.1. And then your R becomes 4 ohms. So that's your R resistor.